Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Okay, we'll move on to lesson 21 today, and our lesson will see us look at what we call convection currents. But before we go on to looking at the information on convection currents, we're going to actually correct the homework that you're supposed to have completed yesterday. Yesterday, we looked at the structure of the Earth, and we found out that the Earth is actually divided into 3 layers. The outermost layer, which is the crust, then the next layer after the crust, which is the mantle, and then the innermost layer, which is the core. Okay, your task yesterday was to look at the different characteristics of each of those layers. We were able to actually complete only one of those layers, and that was the crust. So if we have to recall and revise on what we have actually done already with the information on the crust, you would have found out that we made a list of the following characteristics for the crust, and they are: we said that the crust was actually the thinnest layer. You also mentioned that the crust was thinner under the oceans. It was thick under the continents. You also mentioned that the crust was brittle, and because it was brittle, it was easily, or it could be easily broken, cracked, pushed upwards or downwards, and etc. You also noted that the crust was between 0 to 100 kilometers in terms of its thickness. Someone also mentioned that the crust was the outermost layer, which is correct. I also told you that you forgot that the crust was also made up of the continents and the oceans. And there's also another important feature of the crust that we left out and we must include, and that is, you will find that the crust of the Earth is also broken into what we call rigid plates. So it's broken into plates or tectonic plates, as they are referred to. So those were some of the features or characteristics of this particular section or layer of the Earth, which is known as the crust. Your homework, were you able to actually find out other information that we could also include for characteristics of the crust that we might have left out? Any other features or any other characteristics we need to add to our list? Kathy?
Sustaining of life, like living things.
Okay, very good. That's another important characteristic that we can also include with the information on the information for the crust. Life exists or can be found within this particular layer of the Earth also. You go down to the mantle, you go down to the core, you might not be able to find any form of life. Okay, very good. So we're looking at plants and animals. Humans also, we live where the crust is. Any other information? So we're including to what we have on the monitor, plus what we had written down yesterday. We're including 2 things. One, the crust is broken into rigid plates, and also the crust does contain life. Any other features or characteristics? Okay, if we don't have other features or characteristics, we'll move on now to, this time, the second layer. The second layer of the Earth, and we're going to fill in, like what we did yesterday, the information from the board, and then we can double check with that information after we've collected and put together a picture of the characteristics for the mantle. Catherine, next to you. Oh, sorry. Kathy, next to you. We'll move from that order around and come up to the front for characteristics. This time we are moving to the second layer from the crust down. Can you give me at least one, and the other students can give the rest as we go around the class?
Dense hot layer of semi-solid rock.
Okay, what has been given here? A characteristic, you double check. This particular layer is a dense, hot layer of mainly semi-solid rocks. So if we are looking at semi-solid, what would be another term that you could use to describe semi-solid? Molten. Okay, good. So now you have found out that this second layer, which is the mantle, is actually semi-solid, or you can refer to that layer as being in the state of molten. Any other characteristics, Anita, for the mantle, that is?
The thickness of the mantle is approximately 2,900.
Okay, approximately 2,900 kilometers. Okay, good. The thickness is approximately 2,900 kilometers from the crust. Any other characteristics we can build up of this feature or the second layer, the mantle?
The metal contains iron, magnesium, and calcium elements.
Okay. Contains iron, magnesium, and calcium, of which there are common elements which are now found within this particular layer. Dorothy? Other characteristics?
Hotter and more denser because of temperature and pressure.
Okay, so here we are saying it is dense, it is hot. She's including now temperature and pressure. Note as we go deeper down, temperature increases. That's important that we must make note of. So maybe let's get rid of the information on pressure first, and let's put down temperature decreases. Temperature increases with depth. Okay, so in other words, the further down we go, the hotter it gets, or temperature increases. Other characteristics?
Makes up about 80% of the Earth's volume.
80% of the Earth's volume. Okay, good. Makes up about 80% of the Earth's volume. That's the mantle we're looking at.
There's no life.
Okay, no life. Would you like to explain why you are saying there is no life in this particular layer?
Because it's too hot.
Okay. We note that this particular layer would be hot, therefore any form of life might not be able to exist within the given temperatures. Any other characteristic?
Thought of as the white of the boiled egg.
Sorry, come again?
It is thought of as the white of the boiled egg.
Okay, so if you had to, since Francis is giving us an information here, if you had to make a comparison of the structure of the Earth, and if you had to make a comparison with maybe an item that we know of very well, we could refer to a boiled egg. And the white of the boiled egg can actually be used to make a comparison to what the mantle would actually look like. Okay, we can maybe keep that in mind, because as we go through the readings, we might also come across that information as presented. Thank you. Francis, we move on. Any other characteristics that we need to include?
It behaves like the overlying crust.
It behaves like the
Overlying crust.
overlaying crust. Okay, we'll check this one out. We need some space on this side, so let me get rid of the work on the crust because we've got the information already. Okay, behaves like the overlaying crust. We're basically looking at the uppermost mantle for this particular information, and the uppermost mantle, of which we will refer to later, will be that of the asthenosphere, and I'll explain that later on. Okay, any other characteristics? From the front? Any more to include? No? Gideon?
Pressure increases with depth.
Okay. Pressure increases with depth. Okay, similar to what we've done on temperature. Caleb? No? Okay, so let's check. You double check what you have. If you've got any, if you've got all of those, or if you missed out any of those, you can include to your list. We'll double check now from the monitor. We'll go through the same information. Any of those we've missed out, we can include. So if we look at the characteristics now of the second layer from the crust down, which is the mantle, note that if we check very carefully here, we have not mentioned anything about the thickness also in terms of in comparison to the other two layers. And you will find that maybe Francis was trying to get at looking at the egg, and if you find the boiled egg, you look at the white of the egg, you find that it's the thickest compared to the yolk and the shell. So the mantle is the thickest layer when you're making comparison with the crust and the core. Out of the three layers, it is the thickest layer. You also note that the mantle is the second layer of the Earth's surface, whether you're coming from the center up or whether you're coming from the top down. So if you're coming from the crust down, it is the second layer because you have the crust, the outer layer, the second layer, the mantle, and then the third layer or the inner layer, which is the core. If we're coming from the core up again, the inner layer, the core, then the second layer, the mantle, and then finally the crust. Note the upper layer of the particular layer here, which is the mantle. I'm now looking at the uppermost layer of the mantle, is mainly molten. And that particular layer is referred to as the asthenosphere. We'll explain that when we look at definitions on the chart. Temperature increases with depth. We've explained that already. Contains more iron and magnesium compared to the crust. And another feature which is included there, of which when you had the information from the monitor yesterday, you could have also picked up, and that is the information on the Moho discontinuity. This particular feature is mainly to do with earthquake waves. And when you look at the Moho discontinuity, it is a layer, especially in the second layer of the Earth structure, the mantle, of which when earthquake waves reach that layer, they change speed. And people who study about earthquakes, they note as soon as the waves, they change the speed, they know that the waves have reached a particular layer which is referred to as the Moho discontinuity. And this particular area is found within the mantle. So you can also include that as a characteristic to that particular layer. Okay, beside what is given on the monitor, all the other information that we have also got out here. Dense, hot layer of semi-solid rocks, the thickness to about 2,900 kilometers, good. Pressure increases with depth, behaves like the overlying crust, good, especially the uppermost mantle, the asthenosphere, that is. 80% of the Earth's volume, good. That's also, we can include as one of the characteristics of the mantle. And finally, no life can actually survive or live in that particular layer because of the fact that it is hot. So we've got a general picture of the second layer of the Earth, which is the mantle. We move on now to the last layer, and that is the core. Okay, have we got all that information? Okay, now let's look at the information on the core. Okay, so let's look at the characteristics now of the core. We'll start from our friends right at the back. One of the characteristics. Remember, from what we have looked at yesterday, we can divide the core into the inner core and the outer core. So you can give your information for both. We'll put those together.
Consists of metals such as iron and nickel.
Okay, consists of metals such as iron and nickel, because it's actually been explained a lot of times, those two main elements that are found there. Note, remember when you go back to our work on differentiation, remember on how the materials settle to form the planet Earth. The heavier metals actually, or heavier minerals settle in towards the center. So iron and nickel are actually heavier. So you would find them usually in that particular layer. Okay, good. Rebecca, we move on. Other characteristics?
The outer core is liquid and it is 2,200 kilometers thick.
2,200 kilometers. Okay, so she's given us information here. The outer core is actually liquid, 2,200 kilometers. Another word we can use maybe instead of liquid? Molten, yes. Maybe molten would be another appropriate term that we can use, because when we talk about liquid, some people might already be thinking about water. So we're talking about molten here, okay, when we're referring to this term in this concept. We move on. Other characteristic? Bill?
The inner core, it is about 1,250 kilometer thick solid.
And it is solid, okay? So we find that the information now for the inner core, approximately about 1,500 kilometers thick, and it is believed to be solid. Christopher, any other characteristics?
It contains mainly iron and nickel.
Okay, we come back to here. Contains mainly iron and nickel, good. We can emphasize on that. The inner core or the outer core? Okay, we double check. He says the inner core contains mainly iron and nickel. Okay, so for the statement up here, it's generally the core consists of this. Here he's specifically telling us that the inner core contains mainly iron and nickel. We double check. Do we agree with Christopher? Yes, okay, let's move on. Other characteristics?
It is nearly twice as dense as the metal.
Okay. It is nearly twice as dense as the mantle. Good. That's another characteristic of the core. Mason?
The outer core, where some earthquake waves are absorbed, the Gutenberg discontinuity.
Okay, good. Okay, remember we did the mantle, and for the mantle we said about the Moho discontinuity. And when I talked about the Moho discontinuity, I explained that this is to do with the changing of the speed of earthquake. So as soon as the earthquake waves reach this particular layer in the mantle, that's the Moho discontinuity, they change their speed. People who study about the waves will know straight away, as soon as the waves change speed, they will know that that particular wave has reached this particular layer. In the outer core, the most outer layer of the outer core is this particular area also, which is referred to as the Gutenberg discontinuity. And the Gutenberg discontinuity is the area in the outer core whereby earthquake waves are actually absorbed. They're taken in. So they're absorbed here, the outer core, the most outer area of the outer core. So that's a characteristic you could make note of. Thank you. We move on. Other characteristics of the core?
The outer core spins creating the Earth's magnetic field.
Okay, very good. We are looking at also another important information of the outer core. Note, we said that the outer core is liquid, molten, which means it can move easily. And because the Earth rotates, we note when the Earth actually rotates, the outer core also spins, and that also contributes to the creation of the Earth's magnetic field. Okay, and this is also another important characteristic you could include for the core, and mainly the outer core we're referring to here. The inner core is solid, so this does not concern the inner core. It concerns only the outer core. Other information?
No form of life.
No form of life, okay. Okay, we don't expect to find any form of life here because we know now that it's very, very hot. By the time we reach the center, temperatures would have already increased so much, and also pressure would have also increased. Any other information that we can also include? No? Okay, from the class generally, any other information we might have left out? Okay, over here, Francis got something for us for the core.
It is the center of the Earth.
Okay, we're looking at the center or the innermost layer. Okay, let's maybe use the innermost layer. Thank you, Francis. Okay, so we have the innermost layer. That's a characteristic, definitely, we must also include. Okay, Christopher, to the back. Any other characteristic yet to be included?
The inner core influences the plate tectonic movements.
Okay, so here we're saying the inner core. The inner core definitely does also influence tectonic movement, which is movement of plates on the surface. And that's what we are going to actually look at in our lesson next. Any other characteristic we'll also include here before we go on to the monitor? No? Okay, let's check the information from the monitor. Someone did remember to tell us that it is the innermost layer. Thank you. Temperature range from about 2,000 degrees to 4,500 degrees Celsius. OC, degrees Celsius. Okay, so it's not saying that the temperatures are definitely, but they range between 2,000 to 4,500 degrees Celsius. It is made up of two distinctive parts, of which we found out when we gave our maybe characteristics. The outer core, which is molten nickel and iron, and the inner core, which is mainly solid iron, which is found within the inner core. And all the other characteristics that we have actually looked at, we can also include. Okay, that will conclude our work on finding the information on characteristics of the Earth structure. Note, we know already the three structures are, or not the three structures, but the three layers of the Earth are the crust, the mantle, and the core. And knowing the characteristics, this might be able to help us understand a little bit more on what contributes then to the movement of plates which are on the crust. I'd like us to make reference now to that reading, of which the reading is the one given on inside the Earth. And there would be some points I'd like to actually emphasize on, so I'd like us to go through that information. Okay, you make reference to that reading inside the Earth. From what we have already discovered or studied, note, the size of the Earth, even though we were not told about that, is approximately about 12,750 kilometers in diameter. And we know this, or this was actually known by the ancient Greeks, but it was not until the 10th of the 20th century that scientists determined that our planet is actually made up of 3 layers. And those 3 layers we've discussed already: the crust, the mantle, and the core. This layered structure can be compared to that of a boiled egg, as mentioned earlier on in our lesson. So if we pick up a boiled egg, or if you are now imagining eggs, I hope you're all imagining boiled eggs. The shell of the boiled egg. The shell of the boiled egg is actually very thin in comparison with the egg white and the yolk. So the crust of the earth can actually be referred to as the shell of that egg. And you note that it's very easy for that shell to be broken. It can be cracked and it can be broken easily because it's very thin. The egg white is the thinnest, it's the thickest when you look at the boiled egg. And that can be compared to of the mantle. And then the innermost part of the boiled egg, which is the yolk, can be referred to as the core. It goes on to say that beneath the crust, or beneath the ocean, the crust varies little in thickness, generally extending only to about 5 kilometers in some areas. So the thickness of the crust under the oceans can be as thick as 5 kilometers down to the next layer. So it's very thin, a thin layer that is. And the thickness of the crust beneath the continents is much more variable, but averages to about 30 kilometers. Under large mountain ranges, such as the Alps, the European Alps, that is, and the Sierra Nevada. However, the base of the crust can be as deep as 100 kilometers in thickness. So, like the shell of an egg, the Earth's crust is actually brittle and it can break easily. Below the crust is the mantle, hot layer of semi-solid rock approximately 2,900 kilometers thick. The mantle, which contains more magnesium and calcium than the crust, is actually hotter and denser because temperature and pressure inside the Earth increases with depth. And that's what we have already covered as a characteristic of the mantle. As a comparison, the mantle might be thought of as the white of a boiled egg. At the center of the Earth lies the core, which is nearly twice as dense as the mantle because its composition is metallic, mainly iron and nickel alloy, rather than stony. Unlike the yolk of an egg, however, the Earth's core is actually made up of 2 distinctive parts: a 2,200 kilometer thick liquid outer core and a 1,250 kilometers thick solid inner core. As the Earth rotates, the liquid outer core spins, creating the Earth's magnetic field. Not surprisingly, the Earth's internal structure also influences plate tectonics. The upper part of the mantle is cooler and more rigid than the deep mantle. In many ways, it behaves like the overlying crust. And together, they form a rigid layer of rock which are called the lithosphere, from lithos, Greek word for stone. The lithosphere tends to be thinnest under the oceans and in volcanically active continental areas, such as the western United States, averaging at least 80 kilometers in thickness over much of the Earth. The lithosphere has been broken up into the moving plates that contains the world's continents and oceans. And scientists, they believe that below the lithosphere is a relatively narrow mobile zone in the mantle, which is called the Asthenosphere, from asthens, Greek for weak. This particular zone, the Asthenosphere that is composed of hot, semi-solid material which can soften and flow after being subjected to high temperature and pressure over geological time. And the rigid lithosphere is thought to float or move about on a slowly flowing asthenosphere. And that then would actually summarize what we have looked at on the characteristics of the structure of the Earth. Anyone with any queries or questions you'd like to ask with regards to that? I think with the listing of the characteristic, it has actually helped us understand a little bit more on what is given from the readings. If there are no questions, we'll move on. Okay, so basically what we have already looked at, a cross-sectional view of the Earth from the crust down to the core. Different actually methods or ways of showing the same information. We have the crust, the lithosphere, the asthenosphere, the transitional zone, the mantle, and the core, of which you note the lithosphere should be with the crust, the asthenosphere will be with the mantle, and the core in the center of the Earth, that is. The information that we have looked at already on the essential elements of the internal structure of the Earth, the crust, which is about 10 to 50 kilometers in thickness, averaging continental crust about 35 kilometers thick, and average oceanic crust about 10 kilometers thick. The mantle, from what we have covered, from base of the crust to about 2,900 kilometers below the surface, and the core, which form the base of the mantle, sorry, not form, but from the base of the mantle to the center of the Earth at 6,370 kilometers below the surface. Again, all this information we've already looked at from what we have done on the characteristics. Okay, from that information also, it tells us that from what we have covered so far, it now appears from what we have done on the characteristics of the crust mainly, that the Earth's crust is actually not composed of one large piece, like say the skin of an orange or the skin of an apple. You imagine an apple or an orange. If you have to actually peel the skin of an orange, it's a little bit thick. But if you make a comparison to that of an apple, the skin of an apple is actually very thin. So when we look at the crust, we will find that it is actually not composed of one large piece like the skin of an orange or an apple. But note that the crust of the Earth is actually broken up into large pieces of what we call tectonic plates. These plates, which are on the crust, actually move around slowly. And when they move around, they either collide with each other, or they move away from each other, or they slide past each other. And this is what has actually contributed to what we call the theory or the concept of continental drift. Do you remember scientists long time ago? They said the continents were moving. Were they correct? Yes, definitely. But the only problem is that they were not able to prove to us that the force could have come from somewhere to contribute to that movement. They couldn't prove to us on that one. Our study of the structure of the Earth will help us understand where that force is coming from to contribute to moving of the plates on the surface. So it goes on to say that the energy for the movement of the tectonic plates comes from what we call convection currents. And those convection currents are actually movements in the hot layers of rock beneath the crust of the Earth by the fact that heat rises. That statement you will also find in your booklet. That's the booklet on Introduction to Physical Geography, and that statement can be found on page 4, straight after the activities on Alfred Wegener and the moving continents. So if you want to actually make reference to that information, you can also refer to page 4 for that information. Okay, we'll move on. So here on page 4, we are talking about these convection currents, which are contributing to the movements of the tectonic plates on the surface. So what is that convection current all about again? We go back to the definition, and the definition given in our booklet tells us that convection currents are simply movements in the hot layers of rock beneath the crust, which is caused by the fact that heat rises. You look at the characteristics of the structure of the Earth, you will find out that the further down we go, temperatures increases, pressure increases. So when the temperature is actually increasing, that means it is more hotter. So when it is more hotter, from science you'll also know that the heat will rise. And the rising of the heat from the center of the Earth contributes to the movement of the molten materials, which are mainly found on the second layer of the Earth, which is the mantle. But it is the uppermost layer of the mantle that the movement then contributes to the movement on the surface. And it is that layer which is referred to as the asthenosphere we are referring to. Okay? So if we have to look at this particular idea on convection currents, this is how the convection currents actually operate within the mantle to contribute to movement on the surface or on the crust. You can make reference to your book, page 5, or you can look at the information presented on the monitor. You see, from the core of the Earth, the fact that heat rises, it will contribute then to materials which are mainly of molten to actually move with it up towards the surface. As soon as that material comes to the surface, it comes in contact with the crust. And when it comes in contact with the crust or the lithosphere, it will contribute to the movement of the crust. And the movement can result in plates which are sitting on the surface to move either away from each other or plates moving towards each other. So with Alfred Wegener and all those other scientists, they did not have the convection currents to explain continental drift. Had they known about the structure of the Earth, then they would have come up with that convection current, and then the theory on continental drift would have been accepted long time back. But it was very recently, in the 60s, 1960s that is, that this concept was developed, and as a result, we now today accept the idea on continents moving. The continents, they sit on top of plates. When the plates move, they carry the continents with them. So where is that energy coming from to contribute to the moving of those plates and the continents? It's coming from the convection currents within the mantle. Some of the terms maybe that we need to make reference to when we are studying about convection currents and plate tectonics. Plate tectonics, simply a scientific concept developed in the 1960s to explain the pattern of the Earth's structural components and the mechanism by which they were formed. Asthenosphere. It is a geological term for the zone of the Earth's mantle, which lies immediately below the lithosphere. So if we had to see that in a diagrammatic form, you note the continents, the oceans, of which they both form the crust. So we have the oceans, the continents, both of those form the crust. Then you have the solid lithosphere. So the crust of the Earth actually would be that thin. Still, as we move away from the crust now, we come to this area here, which is the mantle. This whole area here is the mantle. That's directly below the crust. It is this layer here, which we are referring to, which is partly molten, which is the asthenosphere, that contributes then to the movement of the lithosphere, of which the continents which sits on the crust actually moves with that when it moves. So for your homework, what I would like you to do, I would like you to construct a diagram to show how convection currents operate to contribute to movement of the lithosphere or the movement on the crust. That's what I would like you to actually do for your homework. Don't forget, you also are required to make note of the definition to what convection currents are. So you define convection currents, and I'd like you to also do a construction to show how convection currents operate, which results then in the movement of the lithosphere, resulting in the many features that are formed on the surface as a result of that movement. This is actually the force behind plate tectonics. For us to be able to understand plate tectonics, we need to know where the force is coming from. And this is the force which contributes to the movement on the surface. You can make reference to page 4 and 5 for your definition and for the construction of your diagram. And I'd like you to ensure your diagrams are constructed in your exercise book. That will also bring us to the end of our lesson. If you can now stand up. To the pilot teachers, our key word for today is convection. That's for lesson 21. Good afternoon and thank you, class.